Climate change has brought about severe and possibly permanent alterations to our planet. Unregistered trademark geological, biological and ecological systems. The Intergovernmental Panel on Climate Change contended in 2003 that there is new and stronger evidence that most of the warming observed over the last 50 years is attributable to human activity. These changes have led to the emergence of large-scale environmental hazards to human health, such as extreme weather, ozone depletion, loss of biodiversity, stresses to food-producing systems and the global spread of infectious diseases. The World Health Organization estimates that 160,000 deaths, since 1950, are directly attributable to climate change. Many believe this to be a conservative estimate. To date, a neglected aspect of the climate change debate, much less research has been conducted on the impacts of climate change on health, food supply, economic growth, migration, security, societal change, and public goods, such as drinking water, than on the geophysical changes related to global warming. Human impacts can be both negative and positive. Climatic changes in Siberia, for instance, are expected to improve food production and local economic activity, at least in the short to medium term. Numerous studies suggest, however, that the current and future impacts of climate change on human society are and will continue to be overwhelmingly negative. The majority of the adverse effects of climate change are experienced by poor and low-income communities around the world, who have much higher levels of vulnerability to environmental determinants of health, wealth and other factors, and much lower levels of capacity available for coping with environmental change. A report on the global human impact of climate change published by the Global Humanitarian Forum in 2009, estimated more than 300,000 deaths and about $125 billion in economic losses each year, and indicating that most climate change-induced mortality is due to worsening floods and droughts in developing countries. This also raises questions of climate justice, since the 50 least developed countries of the world account for not more than 1% of worldwide emissions of greenhouse gases. Key vulnerabilities. Most of the key vulnerabilities to climate change are related to climate phenomena that exceed thresholds for adaptation, such as extreme weather events or abrupt climate change, as well as limited access to resources to cope. In 2007, the IPCC published a report of key vulnerabilities of industry, settlements, and society to climate change. This assessment included a level of confidence for each key vulnerability: very high confidence, interactions between climate change and urbanization. This is most notable in developing countries, where urbanization is often focused in vulnerable coastal areas. High confidence, interactions between climate change and global economic growth. Stresses due to climate change are not only linked to the impacts of climate change, but also to the impacts of climate change policies. For example, these policies might affect development paths by requiring high-cost fuel choices. Fixed physical infrastructures that are important in meeting human needs. These include infrastructures that are susceptible to damage from extreme weather events or sea level rise, and infrastructures that are already close to being inadequate. Medium confidence, interactions with governmental and social-cultural structures that already face other pressures, for example, limited economic resources. Health. Climate change poses a wide range of risks to population health, risks that will increase in future decades, often to critical levels, if global climate change continues on its current trajectory. The three main categories of health risks include direct acting effects, impacts mediated via climate-related changes in ecological systems and relationships, and the more diffuse consequences relating to impoverishment, displacement, resource conflicts, and post-disaster mental health problems. Climate change thus threatens to slow, halt or reverse international progress towards reducing child undernutrition, deaths from diarrheal diseases and the spread of other infectious diseases. Climate change acts predominantly by exacerbating the existing, often enormous, health problems, especially in the poorer parts of the world. Current variations in weather conditions already have many adverse impacts on the health of poor people in developing nations, and these too are likely to be multiplied by the added stresses of climate change. A changing climate thus affects the prerequisites of population health, clean air and water, sufficient food, natural constraints on infectious disease agents, and the adequacy and security of shelter. A warmer and more variable climate leads to higher levels of some air pollutants and more frequent extreme weather events. It increases the rates and ranges of transmission of infectious diseases through unclean water and contaminated food, and by affecting vector organisms and intermediate or reservoir host species that harbor the infectious agent. Changes in temperature, rainfall and seasonality compromise agricultural production in many regions, including some of the least developed countries, thus jeopardizing child health and growth and the overall health and functional capacity of adults. As warming proceeds, the severity of weather-related disasters will increase, and appears to have done so in a number of regions of the world over the past several decades. Therefore, in summary, global warming, together with resultant changes in food and water supplies, can indirectly cause increases in a range of adverse health outcomes, including malnutrition, diarrhea, injuries, cardiovascular and respiratory diseases, and waterborne and insect-transmitted diseases. Health equity and climate change have a major impact on human health and quality of life, and are interlinked in a number of ways. The report of the WHO Commission on Social Determinants of Health points out that disadvantaged communities are likely to shoulder a disproportionate share of the burden of climate change because of their increased exposure and vulnerability to health threats. Over 90% of malaria and diarrhea deaths are borne by children aged 5 years or younger, mostly in developing countries. Other severely affected population groups include women, the elderly and people living in small island developing states and other coastal regions, megacities or mountainous areas. Psychological impacts. A 2011 article in The American Psychologist identified 3 classes of psychological impacts from global climate change: direct acute or traumatic effects of extreme weather events and a changed environment, indirect threats to emotional well-being based on observation of impacts and concern or uncertainty about future risks, psychosocial chronic social and community effects of heat, drought, migrations, and climate-related conflicts, and post-disaster adjustment, extreme weather events. Infectious disease often accompanies extreme weather events, such as floods, earthquakes and drought. These local epidemics occur due to loss of infrastructure, such as hospitals and sanitation services, but also because of changes in local ecology and environment. For example, malaria outbreaks have been strongly associated with the El Niño cycles of a number of countries. El Niño can lead to drastic, though temporary, changes in the environment such as temperature fluctuations and flash floods. In addition, with global warming, there has been a marked trend towards more variable and anomalous weather. This has led to an increase in the number and severity of extreme weather events. This trend towards more variability and fluctuation is perhaps more important, in terms of its impact on human health, than that of a gradual and long-term trend towards higher average temperature. Diseases. Climate change can lead to dramatic increases in prevalence of a variety of infectious diseases. Beginning in the mid-70s, there has been an A-OE emergence, resurgence and redistribution of infectious diseases a-Euro. Reasons for this are likely multicausal, dependent on a variety of social, environmental and climatic factors. However, many argue that the A-OE volatility of infectious disease may be one of the earliest biological expressions of climate instability a-Euro. Though many infectious diseases are affected by changes in climate, vector-borne diseases, such as malaria, dengue fever and leishmaniasis, present the strongest causal relationship. Observation and research detect a shift of pests and pathogens in the distribution away from the equator and towards Earth's poles. It is estimated that 1/4 of the world a-Euro unregistered trademark S diseases are because of the environmentally based contamination of air, water, soil, and food. It increases in temperatures and the resulting consequences have led to loss of life and decreased well-being of hundreds of thousands of people worldwide. Malaria. Increased precipitation can increase mosquito population indirectly by expanding larval habitat and food supply. Malaria kills approximately 300,000 children annually, poses an imminent threat through temperature increase. Models suggest, conservatively, that risk of malaria will increase 5 to 15% by 2100 due to climate change. In Africa alone, according to the MARA project, there is a projected increase of 16 to 28% in person-month exposures to malaria by 2100. Non-climatic determinants, socio-demographic factors include, but are not limited to, patterns of human migration and travel, effectiveness of public health and medical infrastructure in controlling and treating disease, the extent of anti-malarial drug resistance and the underlying health status of the population at hand. Environmental factors include, changes in land use, expansion of agricultural and water development projects, and the overall trend towards urbanization. Porse and Olson argue that these changes in landscape can alter local weather more than long-term climate change. For example, the deforestation and cultivation of natural swamps in the African highlands has created conditions favorable for the survival of mosquito larvae, and has, in part, led to the increasing incidence of malaria. The effects of these non-climatic factors complicate things and make a direct causal relationship between climate change and malaria difficult to confirm. It is highly unlikely that climate exerts an isolated effect. Environment. Climate change may dramatically impact habitat loss. For example, arid conditions may cause the collapse of rainforests, as has occurred in the past. Temperature. A sustained wet bulb temperature exceeding 35 degrees is a threshold at which the resilience of human systems is no longer able to adequately cool the skin. A study by NOAA from 2013 concluded that heat stress will reduce labor capacity considerably under current emissions scenarios. Water. The freshwater resources that humans rely on are highly sensitive to variations in weather and climate. In 2007, the IPCC reported with high confidence that climate change has a net negative impact on water resources and freshwater ecosystems in all regions. The IPCC also found with very high confidence that arid and semi-arid areas are particularly exposed to freshwater impacts. As the climate warms, it changes the nature of global rainfall, evaporation, snow, stream flow and other factors that affect water supply and quality. Specific impacts include, warmer water temperatures affect water quality and accelerate water pollution. Sea level rise is projected to increase saltwater intrusion into groundwater in some regions. This reduces the amount of fresh water available for drinking and farming. In some areas, shrinking glaciers and snow deposits threaten the water supply. Areas that depend on melted water runoff will likely see that runoff depleted, with less flow in the late summer and spring peaks occurring earlier. This can affect the ability to irrigate crops. Increased extreme weather means more water falls on hardened ground unable to absorb it, leading to flash floods instead of a replenishment of soil moisture or groundwater levels. Increased evaporation will reduce the effectiveness of reservoirs. At the same time, human demand for water will grow for the purposes of cooling and hydration. Displacement and migration. Climate change causes displacement of people in several ways, the most obvious and dramatic being through the increased number and severity of weather-related disasters which destroy homes and habitats, causing people to seek shelter or livelihoods elsewhere. Slow onset phenomena, including effects of climate change such as desertification and rising sea levels, gradually erode livelihoods and force communities to abandon traditional homelands for more accommodating environments. This is currently happening in areas of Africa. Unregistered trademark Sahel, the semi-arid belt that spans the continent just below its northern deserts. Deteriorating environments triggered by climate change can also lead to increased conflict over resources, which in turn can displace people. Extreme environmental events are increasingly recognized as a key driver of migration across the world. According to the Internal Displacement Monitoring Center, more than 42 million people were displaced in Asia and the Pacific during 2010 and 2011, more than twice the population of Sri Lanka. This figure includes those displaced by storms, floods, and heat and cold waves. Still others were displaced drought and sea level rise. Most of those compelled to leave their homes eventually returned when conditions improved, but an undetermined number became migrants, usually within their country, but also across national borders. Asia and the Pacific is the global area most prone to natural disasters, both in terms of the absolute number of disasters and of populations affected. It is highly exposed to climate impacts, and is home to highly vulnerable population groups, who are disproportionately poor and marginalized. A recent Asian Development Bank report highlights OE environmental hotspots that are particular risk of flooding, cyclones, typhoons, and water stress. To reduce migration compelled by worsening environmental conditions, and to strengthen resilience of at-risk communities, governments should adopt policies and commit financing to social protection, livelihoods development, basic urban infrastructure development, and disaster risk management. Though every effort should be made to ensure that people can stay where they live, it is also important to recognize that migration can also be a way for people to cope with environmental changes. If properly managed, and efforts made to protect the rights of migrants, migration can provide substantial benefits to both origin and destination areas, as well as to the migrants themselves. However, migrants particularly low-skilled ones are among the most vulnerable people in society and are often denied basic protections and access to services. The links between the gradual environmental degradation of climate change and displacement are complex. As the decision to migrate is taken at the household level, it is difficult to measure the respective influence of climate change in these decisions with regard to other influencing factors, such as poverty, population growth or employment options. This situates the debate on environmental migration in a highly contested field. The use of the term environmental refugee, although commonly used in some contexts, is disrecommended by agencies such as the UNHCR, who argue that the term refugee has a strict legal definition which does not apply to environmental migrants. Neither the UN Framework Convention on Climate Change nor its Kyoto Protocol, an international agreement on climate change, includes any provisions concerning specific assistance or protection for those who will be directly affected by climate change. In small islands and megadeltas, inundation as a result of sea level rise is expected to threaten vital infrastructure and human settlements. This could lead to issues of statelessness for populations in countries such as the Maldives and Tuvalu, and homelessness in countries with low-lying areas such as Bangladesh. Security conflicts are typically extremely complex with multiple interdependent causalities, often referred to as complex emergencies. Unregistered trademark climate change has the potential to exacerbate existing tensions or create new ones. Serving as a threat multiplier. It can be a catalyst for violent conflict and a threat to international security. Climate change does not always lead to violence, as there are a number of other factors that contribute to why conflict between groups occurs. The United Nations Security Council held its first ever debate on the impact of climate change in 2007. The links between climate change and security have been the subject of numerous high-profile reports since 2007 by leading security figures in the United States, United Kingdom and the European Union. The G77 group of developing nations also considers climate change to be a major security threat which is expected to hit developing nations particularly hard. The links between the human impact of climate change and the threat of violence and armed conflict are particularly important because multiple destabilizing conditions are affected simultaneously. Experts have suggested links to climate change in several major conflicts: war in Darfur, where sustained drought encouraged conflict between herders and farmers; Syrian civil war, preceded by the displacement of 1.5 million people due to drought-induced crop and livestock failure; Islamist insurgency in Nigeria, which exploited natural resource shortages to fuel anti-government sentiment; Somali civil war, in which droughts and extreme high temperatures have been linked to violence; social impacts. The consequences of climate change and poverty are not distributed uniformly within communities. Individual and social factors such as gender, age, education, ethnicity, geography and language lead to differential vulnerability and capacity to adapt to the effects of climate change. Climate change effects such as hunger, poverty and diseases like diarrhea and malaria, disproportionately impact children, that is about 90% of malaria and diarrhea deaths are among young children. Social effects of extreme weather. As the World Meteorological Organization explains, recent increase in societal impact from tropical cyclones has largely been caused by rising concentrations of population and infrastructure in coastal regions. PKL normalized mainland U.S. hurricane damage from 1900 to 2005 to 2005 values and found no remaining trend of increasing absolute damage. The 1970s and 1980s were notable because of the extremely low amounts of damage compared to other decades. The decade 1996-2005 has the second most damage among the past 11 decades, with only the decade 1926-1935 surpassing its costs. The most damaging single storm is the 1926 Miami hurricane, with $157 billion of normalized damage. The American Insurance Journal predicted that catastrophe losses should be expected to double roughly every 10 years because of increases in construction costs, increases in the number of structures and changes in their characteristics. The Association of British Insurers has stated that limiting carbon emissions would avoid 80% of the projected additional annual cost of tropical cyclones by the 2080s. The cost is also increasing partly because of building in exposed areas such as coasts and floodplains. The ABI claims that reduction of the vulnerability to some inevitable effects of climate change, for example through more resilient buildings and improved flood defenses, could also result in considerable cost savings in the long term. Human settlement. A major challenge for human settlements is sea level rise, indicated by ongoing observation and research of rapid declines in ice mass balance from both Greenland and Antarctica. Estimates for 2100 are at least twice as large as previously estimated by IPCC AR4, with an upper limit of about 2 meters. Depending on regional changes, increased precipitation patterns can cause more flooding or extended drought stresses water resources. Coasts and low-lying areas. For historical reasons to do with trade, many of the world's largest and most prosperous cities are on the coast. In developing countries, the poorest often live on floodplains, because it is the only available space, or fertile agricultural land. These settlements often lack infrastructure such as dikes and early warning systems. Poorer communities also tend to lack the insurance, savings, or access to credit needed to recover from disasters. In a journal paper, Nichols and Toll considered the effects of sea level rise. The most vulnerable future worlds to sea level rise appear to be the A2 and B2, IPCC scenarios, which primarily reflects differences in the socio-economic situation and GDP per capita, rather than the magnitude of sea level rise. Small islands and deltaic settings stand out as being more vulnerable as shown in many earlier analyses. Collectively, these results suggest that human societies will have more choice in how they respond to sea level rise than is often assumed. However, this conclusion needs to be tempered by recognition that we still do not understand these choices and significant impacts remain possible. The IPCC reported that socio-economic impacts of climate change in coastal and low-lying areas would be overwhelmingly adverse. The following impacts were projected with very high confidence. Coastal and low-lying areas would be exposed to increasing risks including coastal erosion due to climate change and sea level rise. By the 2080s, millions of people would experience floods every year due to sea level rise. The numbers affected were projected to be largest in the densely populated and low-lying mega-deltas of Asia and Africa. And smaller islands were judged to be especially vulnerable. A study in the April 2007 issue of Environment and Urbanization reports that 634 million people live in coastal areas within 30 feet of sea level. The study also reported that about two-thirds of the world's cities with over 5 million people are located in these low-lying coastal areas. Energy sector, oil, coal and natural gas. Oil and natural gas infrastructure is vulnerable to the effects of climate change and the increased risk of disasters such as storm, cyclones, flooding and long-term increases in sea level. Minimizing these risks by building in less disaster-prone areas can be expensive and impossible in countries with coastal locations or island states. all thermal power stations depend on water to cool them. This has to be fresh water, as salt water can be corrosive. Not only is there increased demand for fresh water, but climate change can increase the likelihood of drought and freshwater shortages. Another impact for thermal power plants is that increasing the temperatures in which they operate reduces their efficiency and hence their output. The source of oil often comes from areas prone to high natural disaster risks, such as tropical storms, hurricanes, cyclones, and floods. An example is that of Hurricane Katrina's impact on oil extraction in the Gulf of Mexico, as it destroyed 126 oil and gas platforms and damaged 183 more. However, previously pristine Arctic areas will now be available for resource extraction. Nuclear, climate change, along with extreme weather and natural disasters, can affect nuclear power plants in a similar way to those using oil, coal, and natural gas. The damage caused to nuclear power plants is most tragically demonstrated by the Fukushima Daiichi nuclear disaster. However, the impact of water shortages on nuclear power plants is perhaps more visible than on other thermal power plants. Seawater is corrosive, and so nuclear energy supply is likely to be negatively affected by a freshwater shortage. This generic problem may become increasingly significant over time. This situation could subsequently force nuclear reactors to be shut down, as happened in France during the 2003 and 2006 heat waves. Nuclear power supply was severely diminished by low river IR rates and droughts, which meant rivers had reached the maximum temperatures for cooling reactors. During the heat waves, 17 reactors had to limit output or shut down. 77% of French electricity is produced by nuclear power. And in 2009 a similar situation created a 8GW shortage, and forced the French government to import electricity. Other cases have been reported from Germany, where extreme temperatures have reduced nuclear power production 9 times due to high temperatures between 1979 and 2007. In particular, the Unterweser nuclear power plant reduced output by 90% between June and September 2003. The Isar nuclear power plant cut production by 60% for 14 days due to excess river temperatures and low stream IR in the river Isar in 2006. Similar events have happened elsewhere in Europe during those same hot summers. Many scientists agree that if global warming continues, this disruption is likely to increase. Hydroelectricity, changes in the amount of river flow will correlate with the amount of energy produced by a decomitter. Lower river flows because of drought, climate change, or upstream dams and diversions, will reduce the amount of live storage in a reservoir, therefore reducing the amount of water that can be used for hydroelectricity. The result of diminished river flow can be a power shortage in areas that depend heavily on hydroelectric power. The risk of flow shortage may increase as a result of climate change. Studies from the Colorado River in the United States suggests that modest climate changes might reduce river runoff by up to 40%. Brazil in particular is vulnerable due to its having reliance on hydroelectricity, as increasing temperatures, lower water IR, and alterations in the rainfall regime could reduce total energy production by 7% annually by the end of the century. Insurance, an industry directly affected by the risks of climate change, is the insurance industry. According to a 2005 report from the Association of British Insurers, limiting carbon emissions could avoid 80% of the projected additional annual cost of tropical cyclones by the 2080s. A June 2004 report by the Association of British Insurers declared climate change is not a remote issue for future generations to deal with. It is, in various forms here already, impacting on insurers' businesses now. The report noted that weather-related risks for households and property were already increasing by €4% per year due to the changing weather conditions, and claims for storm and flood damages in the UK had doubled to over £6 billion over the period from 1998 to 2003 compared to the previous 5 years. The results are rising insurance premiums, and the risk that in some areas flood insurance will become unaffordable for those in the lower income brackets. Financial institutions, including the world's 2 largest insurance companies, Munich Re and Swiss Re, warned in a 2002 study that the increasing frequency of severe climatic events, coupled with social trends, could cost almost $150 billion each year in the next decade. These costs would burden customers, taxpayers, and the insurance industry, with increased costs related to insurance and disaster relief. In the United States, insurance losses have also greatly increased. It has been shown that a 1% climb in annual precipitation can increase catastrophe loss by as much as 2.8%. Gross increases are mostly attributed to increased population and property values in vulnerable coastal areas. Though there was also an increase in frequency of weather-related events like heavy rainfall since the 1950s. Transport, roads, airport runways, railway lines and pipelines may require increased maintenance and renewal as they become subject to greater temperature variation. Regions already adversely affected include areas of permafrost, which are subject to high levels of subsidence, resulting in buckling roads, sunken foundations, and severely cracked runways. See also, food security, environmental security and peace, long-term effects of global warming, references. Further reading, Addressing Climate Change in Asia and the Pacific 2012, Climate Change 2007, Synthesis Report, 4th Assessment Report, Intergovernmental Panel on Climate Change, Report on the Economics of Climate Change, Stern Review, Human Impact Report, The Anatomy of a Silent Crisis, Global Humanitarian Forum, Key Points on Climate Justice, Working Paper of the Global Humanitarian Forum, What Happened to the Seasons? Oxfam Research Reporter, Human Development Report 2007/2008, United Nations Development Programme, McClecroft Climate Change Risk Report 2009/2010, Woodward, A Doctoring the Planet, Health Effects of Global Change. Australian and New Zealand Journal of Medicine 25, 46 €53 doi, 10.1111 per Joule 1445-5994.1995 TB00579X. ISNA 0004-8291. PMIDA 7786246. UNESCO Migration and Climate Change, Piguet, E., Par Copyright Cowd, A. and Daguchniara, P. Migration and Climate Change, An Overview, Climate Change, Water Stress, Conflict and Migration Proceedings of the Conference in The Hague, September 2011, External links, Global Humanitarian Forum, TCK Time for Climate Justice Campaign, United Nations Environment Programme and Climate Change, Office of the High Commissioner for Human Rights and Climate Change, Office of the High Commissioner for Refugees Climate Change, CARE International Climate Change Information Center, Red Cross Red Crescent Climate Center, World Bank and Climate Change, World Meteorological Organization and Climate Change and Human Health on World Health Organization, International Alert Climate Change and Violent Conflict, International Strategy for Disaster Reduction, Disaster Risk Reduction and Climate Change.